In this video, we are going to talk about significant figures. We will also cover how to round numbers. And then lastly, we'll talk about addition, subtraction, multiplication, and division of significant figures. But we are going to talk about these significant figures in light of chemistry. Significant figures are a little bit different in other disciplines, but here we'll focus on how it is done in chemistry. How many significant figures are in the number 9784? So the number is 1, 2, 3, 4. So four numbers. So there are four significant figures. What about 38621? 1, 2, 3, 4, 5. So there are five significant figures. What about 457? 1, 2, 3. So three significant figures. The reason is because all non-zero numbers are significant. Now, how many significant figures are in 7001? There are four significant figures. What about 502? These are three significant figures. What if we were having the number 8339079? So 1, 2, 3, 4, 5, 6, 7. So these are seven significant figures. The reason is because zeros between non-zero numbers are significant. So if you have zeros that has been sandwiched between non-zero numbers, then you count them as part of the significant figures. Now, what if we were given 1.000 times 10 exponent 7? How many significant figures are here? So you see that there are four significant figures here. What about 700 points? How many significant figures? There are three significant figures here. What about 90000 points? And this one too, 1, 2, 3, 4, 5. There are five significant figures. What about 10 points? So 1, 2. There are two significant figures. So if you see trailing zeros, that means zeros either at the back of a decimal point or zeros that end with a decimal point, then they are counted as significant figures. So trailing zeros are significant if they have a decimal point. So anytime you see trailing zeros but you see a decimal point, then you count them as part of significant figures. Now, let's come to this point. How many significant figures are in the number 80,000? So you see that there is only one significant figure in 80,000. What about 16,740? So 1, 2, 3, 4. These have four significant figures. What about 300? 300 has one significant figure. Now, anytime you see zeros, trailing zeros, then that does not have any point, decimal point, then the zeros are not counted as part of significant figures. So final zeros without a decimal point are not significant. This is different from, let's say, if we're having 80,000. This is 80,000 dot. 80,000 dot has five significant figures. However, 80,000 without a dot has got one significant figure. So these are the differences between them. So in this case too, if we are having 300 dots, then 300 dots will be three significant figures. However, 300 is one significant figure. So these are the differences between them. What about if we are having 0.0017? How many significant figures are here? So when you see leading zeros, then leading zeros are insignificant, whether there is a decimal point or not. Leading zeros are insignificant. So in this case, the non-zero numbers are 1, 2. So this is two significant figures. Then what about 0.00010? So you see that these leading zeros are 3. They are insignificant. However, a trailing zero is here, which is significant. So here's 1, 2, and therefore this is two significant figures. What about 0.00143? So these are two leading zeros, insignificant. So 1, 2, 3. So this is three significant numbers. So leading zeros to the left of first non-zero digits are never counted as significant. Determine the number of significant figures in each of the following. So A, 1001. So 1, 2, 3, 4, 5. So these are 5 significant figures. You can pause the video and try. Then B, 11000. So we have trailing zeros, and since we don't have a point, then these are only two significant figures. However, we have 11000 point, then that means that these zeros are significant and becomes 1, 2, 3, 4, 5. So these are 5 significant figures. Then here's 0.00011. Leading zeros are insignificant, and therefore here is only two significant figures. Then 11.000. Trailing zeros that have a point are significant, and therefore here's 5 significant figures. Then 11. Non-zero numbers are significant, and therefore these are two significant figures. How many significant figures are in each of the following numbers? A, 3.003. So 1, 2, 3, 4. 3.003 has 4 significant figures. And here is 6.023. So this one too is 1, 2, 3, 4. So this one too has 4 significant figures. Then here is 9,000. Now these are trailing zeros. So trailing zeros without a point are insignificant, and therefore here is only one significant figure. And here is 1.0300. So anytime you see a point in a number, then all the trailing zeros become significant. So here becomes 1, 2, 3, 4, 5. So here's 5 significant figures. Now let's talk about rounding numbers. If we are having 35,670.06 and we are asked to round it to 4 significant figures, how do we round this number? So in terms of 4 significant figures, this will be 1, 2, 3, 4. So these are 4 significant figures. So it's going to be 3567. However, because trailing zeros are insignificant, then we need to add it so that we don't change the value of the number. You see, this is in tens of thousands. But if we just write 3567 as 4 significant figures, it changes the value of the number. This is no more in tens of thousands. This is now in thousands. So to keep the number in tens of thousands, then we need to add a trailing zero. But a trailing zero is insignificant, and therefore this is still 4 significant figures. Now, let's write this same number in 6 significant figures. So if it is 6 significant figures, this will be 1, 2, 3, 4, 5, 6. However, the following number is what? 6. If a number is 5, greater than 5, then we need to add 1 to the previous number. But if it's less than 5, then we need to keep it the same. And since 6 is greater than 5, then we need to add 1 to this 0 to be 0.1. And therefore, this is going to be 35670.1. And this is in 6 significant figures. Now, let's write the number 4.995 times 10 exponent 3 in 3 significant figures. So if it is 3 significant figures, here is going to be 1, 2, 3. So it's going to be 4.99. but we have a 5. What we spoke about was when the number is greater than 5 or less than 5. What if we have 5? Now, the rule says that if we have 5, we need to check the numbers that comes after the 5. If they are non-zero numbers, then we need to add 1 to this previous number. But if there is no number or there are 0 numbers, then we need to leave the number just as it is. So in this case, you see that after the 5, there is no number there, and therefore this in 3 significant figures is going to be 4.99 in 3 significant figures rounded up. However, let's assume this is 4.99 times 10 exponent 3 in 3 significant figures. However, let's assume that the number was 4.995. Then maybe it was 1 or 1, 2, something like that. Then in this case, we cannot ignore this 5. So in this case, it becomes, if we add 1 to this, all becomes 5. So this will become 5.00 in 3 significant figures. So these are the differences. Now let's round the number 68.507 in 2 significant figures. What will we get? So 2 significant figures is going to be 68. But there's this number here which is 0.5. Now if you check, after 0.5, there's a 0 and then a non-zero number, and therefore we cannot ignore this 5. So we need to round it up by adding 1 to the 68 to give us 69 in 2 significant figures. Then let's round the number 2.30985 times 10 exponent minus 4 in 5 significant figures. So 5 significant figures, this is 1, 2, 3, 4, 5. Now we have this 5 here, but after this 5, there is non-zero numbers here. There is no number actually here, and therefore we need to ignore the 5, and this will become 2.3098 times 10 exponent minus 4 in 5 significant figures. Let's talk about addition and subtraction of significant figures. So let's add 3.18 and 0.01315. Anytime you are adding or subtracting significant figures, then the most important thing is that the final number must be, the decimal places of the final number must be corresponding to the least number among the numbers. So what we mean is that since here there are 2 decimal places, and that is the least between these 2 numbers, then the final answer must have 2 decimal places. So you use calculator to do this. If you use calculator to add them, then you get 3.19315. Nonetheless, we need to leave them in 2 decimal places because that's the least here. Because here is 1, 2, 3, 4, 5 decimal places. So therefore here will be 3.19. So 2 decimal places. Now let's add 6.002 and 3.179284. If we do the addition, we are going to get 9.181284. However, here is 3 decimal places, and then this place is 1, 2, 3, 4, 5, 6 decimal places. So the final answer must be in 3 decimal places because that's the least among these 2 numbers. And therefore, this is 9.181 in 3 decimal places. Subtract 7.9801 from 2.2. If you use the calculator to do the subtraction, you get 5.7801. However, here is 1 decimal place, and here is 4 decimal places. So the final answer must be in 1 decimal place, and therefore this becomes but the number preceding the last decimal place is greater than 5. So we need to add 1 to it. This will become 5.8 in 1 decimal places. Indicate the number of significant figures in each of the following. A, 57.11. So this is 4 significant figures. Here is 8.070. 1, 2, 3, 4. Here too is 4 significant figures. And here is 0.0105. Leading zero sign significant. So here becomes 1, 2, 3. Therefore, this is 3 significant figures. 9.7750. So trailing zeros that have a decimal in it are significant, and therefore these are 5 significant figures. Now here he says that round each of the following numbers to 4 significant figures. Yes, 1, 2, 3, 4. So this place is going to be 300.2. Let me write them here. Okay, let me write them here. So this is equal to 300.2. Then here is 4 significant figures. Leading zeros are insignificant. So the first significant figure is 1, 2, 3, 4. But now we have a 5 and then a 0. But remember that if after the 5, the numbers are, so if after the 5, there is either a 0 or there are no numbers at all, then we would ignore rounding of the 5 to 1. So this will become equal to 0.000, then 9579. So that is this number in 4 significant figures. The reason why we didn't add this 5 is that after the 5 is a 0. It is not a non-zero number, so we cannot consider this 5. So here is 1, 2, 3, 4. You see there's a 5 here, but after the 5 there are 3 non-zero numbers, and therefore we need to consider the 5 in this case. So this will become equal to 4809. However, this number, the numbers here are also significant, but we need to round it up. So we need to add 3 zeros to it. 4 zeros. So that we don't lose the value of the number. So this is 4 significant figures. However, the number is still intact. And this one is 1, 2, 3, 4. So there's a 5 here. But this 5, after the 5, there is 0. There's no number, so we don't need to consider this 5. Therefore, this is 1922. But we don't need to lose the value of the number because it is in hundreds of thousands. So therefore, we have to add a 0 to this. So it becomes 19220. Let's perform the following calculations. 3,600 minus 15.44 plus 250.2. So you see that since it is addition and subtraction, then the most important thing here is the number of decimal places. So here is a 0 decimal place. This is 2 decimal places. And then here is 1 decimal place. It means that the least is 0 decimal places, and therefore our final answer must be a 0 decimal place. So if you use a calculator to do this addition and subtraction, you are going to get the number. So this is equal to 3834.76. However, we need to write this number in terms of 0 decimal places. But after the 4, there is a number here which is greater than 5. So we need to add 1 to this 4. And therefore, this will become 3834. So that is the final answer for this. And then with this one, all we need to do is to first do the subtraction on top. And then after we do the subtraction, then we then do the division. So if you do the subtraction, since it is addition and subtraction, then what is important here is decimal places. Then after when we do the division, the most important thing that will be number of significant figures. So here is 2 decimal places, and this place is 1 decimal place. So if we do this subtraction, we need to leave it in one decimal place. So if you use calculator to do this subtraction, we are going to get this is equal to 4.8382 divided by 1.05 times 10 exponent 4. So we need to write this in terms of one decimal place, and that is going to give us 4.8 divided by 1.05 times 10 exponent 4. And if you use the calculator to do this, then we are going to get this is equal to 4.571429 times 10 exponent negative 4. So what we need to do is to write this number in terms of the least number of significant figures. So if you see here, it is 2 significant figures, and here it is 3 significant figures. Therefore, we need to write this number in 2 significant figures. Here's 2. So it's going to give us, you see after this 5, 7 is greater than 5. Therefore, we need to add 1 to it. It's going to give us 4.6 times 10 exponent minus 4. Now, if you use a calculator to do this one, you are going to get 87.711. But you see, here is 1 decimal place, here is 2 decimal places, and this place too is 2 decimal place. So we need to write this number in terms of 1 decimal place, and that will give us 87.7. 5.556 times 2.3 divided by 4.223 minus 0.08. So we need to first do the addition and subtraction down here. Here's 3 decimal places, and here's 2 decimal places. So we need to first do this subtraction and leave it in 2 decimal places. And if you use a calculator, here is going to give us 5.5. So sorry, but we need to also do this multiplication and leave it in terms of 2 significant figures, because here's 2 significant figures and this place is 4 significant figures. So if we use calculator to do this multiplication, we're going to get 12.7788. And if we use it for this subtraction, we will get 4.143. So write this in 2 significant figures, and that's going to give us 13. And then write this in 2 decimal places, and that's going to give us 4.14. Now we then have to do this final division. 13 divided by 4.4, that's equal to 3.1400966,184. But then we need to write this number in terms of the least number of significant figures. And here's 2 significant figures, and here's 3 significant figures. So we need to leave the final answer in 2 significant figures. And that is going to give us 3.1 in 2 significant figures. Let's come to this case. So let's do this subtraction. If we do the subtraction, we are going to get 3.18 divided by 5.233 times 0.205. So we can use calculator to do this. Now we wouldn't worry because this final answer is in 2 decimal places, and the least here is 2 decimal places. So let's use this calculator to do this. If we do 13.18 divided by 5.233 times 0.205, we are going to get 0.1245748,137. Then now see, here is 3 significant figures, and here is 4 significant figures, and here is also 3 significant figures. So we need to write this number in 3 significant figures. That's going to give us 0.125 in 3 significant figures.